Hello friends, welcome to Studybay Technologies, and in our today's session we are going to solve the question paper for today's test. Now it's about the application of trigonometry, that is height and distance. So the first question is, a person standing on the bank of a river observes that the angle subtended by a tree on the opposite bank is 60 degrees. When he retreated 20 meters back from the bank, he finds the angle to be 30 degrees. Find the height of the tree and breadth of the river. Now let's try to solve this question. Let's say this is a river, fine, and a person is standing on the bank, and there is a tree on the opposite bank, and it's something like this, right? Now that tree subtends an angle of 60 degrees when it is viewed from the back. After that, this man retreats 20 meters back, and now the angle became 30 degrees. So now let me put it up. It's 60 degrees. This is 30 degrees, and he retreated for a distance of around 20 meters. Okay. Now let's say height of this tree is h and the breadth of the river is x. Alright. Now let me label this entire diagram. We have A, B, C and D. Okay. Now this is, as you can clearly see it, this is perpendicular. And now we can use the concept of trigonometry to find out the height and breadth of the river. So the first thing, that is tan x tan 60 degree, this is equals to h upon x. Tan 60 degree is under root 3. This is equal to h upon x, and so this h equals to root 3 times of x. Alright, now you may consider this as a first equation like this. Then we have tan 30 degree. This is equal to h upon x plus 20. Right? Now tan 30 degree is 1 upon root 3. This is equal to h upon x plus 20. Okay. Now this x plus 20, this is equal to root 3h. Alright. You can consider this as a second equation. Now as you can see that this h equals to root 3x, so you can put the value of h in the second equation. Then what will happen? This is x plus 20 equals to root 3 into root 3 x, and so this x plus 20, this will be equal to 3x, because you know that root 3 into root 3 will be 3, and so finally this 2x will be equal to 20, and x will be equal to 10, right? So we can say that the breadth of the river is 10 meter. Alright, you can highlight this, and this part is done. Now, height of the tree, as you can see from the first equation, that is height, this is equal to 10 root 3. Or if you solve it, then in that case, this h will be equal to 1.732 is the value of under root 3. 1.732 multiplied by 10, that is 17.32. Fine. And that's your final answer. That is, height of the tree is 17.32 meters and the breadth of the river is 10 meters. Moving on to the next question. A tree is broken by the wind. The top struck the ground at an angle of 30 degrees and at a distance of 30 meters from the root. Find the whole height of the tree. So let's go ahead. So as per the question, like this is the ground. Okay. Now we have a tree, and this tree has been broken down, and it is something like this. Fine. Now this is making an angle of 30 degrees, and the point where the top of the tree touches the ground is around 30 meters away from the roots. So this should be around 30 meters. Fine. Now let's consider that this is perpendicular, right? Now if I can find out the height of this x and this y, we can find out the length of this x and y, we can add them and we will find the exact height of the tree, right? So how can we go ahead? Simple, that is, first of all put tan 30 degree equals to x upon 30, right? Now tan 30 degrees is 1 upon root 3. This is equal to x upon 30. Now x equals to 30 upon root 3. And so, like, if you rationalize this, you will be doing it like root 3 upon root 3. That will be equal to 30 root 3, and that's equal to finally 10 root 3. So x is equal to 10 root 3, or it will be equal to 17.32 meter, right? We can consider this as a first point. Now about y, we can say cos 30 degree. This is equals to base upon hypotenuse. Now we can put y equals to 30 upon cos 30 degree, right? Now what will be the value of cos 30 degree? This is root 3 by 2, that is 30 upon 2 into root 3. Again you can simply rationalize it. This will be root 3 upon root 3. Now y equals to 60 root 3 upon 3. That will be equal to 20 root 3. And so this y will be equal to 20 root 3, or you can calculate the value as well directly as you have done in this case. Now the height of the tree, this can be calculated by just adding x and y. This will be 10 root 3 plus 20 root 3, and that's equals to 30 root 3. 30 root 3 meter, right? You can also calculate it in decimal terms by multiplying it 30 by 1.732, right? Now let's move to the next question. The next question states that the angles of elevation of the top of a tower from 2 points at a distance of p meters and q meters from the base and in the same straight line with it are complementary. Prove that height of the tower is under root pq. Okay, let's go ahead. Let's say this is the base and here we have a tower, alright, and there are 2 points which are at a distance of p and q meters from the base. This is, let's say, p meter, and this one is, let's say, q meter. Fine. Okay, now it says that the angles are complementary, right? That means if this angle, complementary angle means these are those angles whose sum is 90 degree. Okay, so this angle is theta, so this must be 90 minus theta. Fine. Let's say height of the tower is h. Okay, now going forward, we have to prove that the height of the tower is under root pq. So let me write it for you. That is, we have to prove h equals to under root pq. Now here we can use this tan theta equals to h upon p, alright, and so this h can be equal to p tan theta, alright. This is first point. Now next case is tan 90 minus theta. This will be equal to h upon q. Now tan 90 minus theta is cot theta. This cot theta will be equal to h upon q, right? Now what is this cot theta is? Cot theta is actually 1 upon tan theta. Now 1 upon tan theta, this is equal to h upon q, and so this tan theta can be written as q upon h. Now if we consider this equation as first one, we can say that tan theta equals to h upon p, and here it says tan theta equals to q upon h, right? We can equalize both these equations because in both cases the right hand side is equal to the tan theta only. So we can write it as q upon h equals to h upon p. Now we can perform a cross multiplication. This will be h square equal to pq, and so this h will be equal to under root pq, and this is what we are supposed to prove. That's the final answer. Fine. Now let's move to the next question. At a point on level ground, the angle of elevation of a vertical tower is found to be such that its tangent is 5 upon 12. On walking 192 meters toward the tower, the tangent of angle of elevation is 3 upon 4. Find the height of the tower. Alright, let's go ahead. First of all, let's say this is question number 4. This is a level ground, and here, this point, we have a tower. Okay, now, yeah. So at this case, the angle of elevation is tangent of angle of elevation. Sorry, let's say the angle is x, right? And in that case, the tan x is found to be 5 upon 12. Okay, I have no idea about what is the angle and how far is it from the star or so on. But what I observed is after moving a distance of 192 meters towards the tower, let's say this is 192 meters, I move from this point to this point. Let's say I move from point A to point B. The angle of elevation changes to y, and in that case, this tan y, this becomes here 3 by 4. Fine. So tan y becomes 3 by 4. Now, what we have to find is we have to find the height of the tower. So let's say the height of the tower is h. Alright. Now in that case, this tan x, this will be equal to, let's say, before that, let me label the entire figure. This is A, B, C, and D. Okay. Let's say this point BC is A. Some distance is that. Let's say this is A. Now tan x, this will be equal to h upon A plus 192. Alright. Now what is the value of tan x? This is 5 upon 12. So this is 5 upon 12 equals to h upon A plus 192. Now finally h, this will be equal to 5 times of A plus 192 whole upon 12. Alright. In the same way, tan y, this will be equal to h upon A. Now tan y equals to 3 upon 4, and so this will be equal to h upon A. Now h will be equal to 3a upon 4. Now this is equation number 1. This is equation number 2. Now in both cases, left hand side is 3a, sorry, h actually. So we can put it like 3a upon 4. This is equal to 5a plus 192 upon 12. So this is 4, 3, 12, and then you can make a cross multiplication. This is 9a equals to 5a plus 5 into 192. No need to multiply it directly. Just put it 9a minus 5a, that is 4a equals to 5 into 192. Now a will be equal to 5 into 192 upon 4. This is 4, 4, 16, 4, 8, 32. Now finally, this a will be equal to 8, 5, 40, and this is 240 meter. So a will be equal to 240 meter. Now height will be equal to, according to the second equation, 3 times into 240 upon 4, and so this will be 3 and this will be cancelled out to 60, and that's equal to 180 meter. So the height of the tower will be 180 meters. Fine. Now move on to the next question. The question is, a person standing on the bank of a river observes that the angle of elevation of the top of a tree standing on the opposite bank is 60 degrees. When he moves 40 meters away from the bank, he finds that the angle of elevation to be 30 degrees. Find the height of the tree and the width of the river. So this is almost same as the question number 1. Let me help you to solve it. This is question number 5. Here, this is a river. Fine. Now, there is a tree on one bank, one of the bank. Let's say this is a tree, and a person is standing over here. Observe that the top of the tree and finds out that the angle of elevation is 60 degrees. Alright. Now he moves around let's say 40 meters away from the bank. Like this. And now once he look at that tree, found that the angle of elevation is now 30 degrees. Okay. Now let me label this figure. This is A, B, C, and D. The distance over here is between CD is 40 meter. Now let's say this width is X and the height of the tree is H. Okay. Now if we try to solve it, we can say that this is tan 60 degree equals to H upon X. Now what is the value of tan 60 degree? This is equal to under root 3 equals to H upon X. Or this H, this will be equal to under root 3 X. Fine. Now let's take this one. Tan 30 degrees. This is equal to H upon X plus 40. Tan 30 degrees is 1 upon root 3. This is equal to H upon X plus 40. Alright. Now this H will be equal to X plus 40 upon root 3. You can take it as a second relation. So this is our first equation and this is our second equation. Fine. Now you can see that both sides, just left hand side is H. So we can say that yes, we can equalize both of them. It's like under root 3x equals to x plus 40 upon root 3. Now if we we can perform a cross multiplication. This will be 3x equals to x plus 40. Now 3x, we can do this 3x minus x, that will be equal to 2x, and 2x equals to 40, and so this x will be equal to 20 meters. This is the first value. Fine. Now about the h, that is the height of the tower. Width of the river is now 20 meter, and height will be equal to h as per the first equation, that is 20 root 3 meter. Fine. So height of the tower is 20 root 3 and width of the river is 20 meter. So that's your final answer. Now let's move on to the next question. A man on the top of a vertical tower observes a car moving at a uniform speed coming directly toward it. If it takes 12 minutes for an angle of depression to change from 30 degree to 45 degree, how soon after this will the car reach the tower? Right? So you can answer this question to the nearest second answer. Let's go ahead. This is question number 6. This is a plain ground, and here this is a tower. Alright. Now if we find out the angle of depression, first of all what we have to do is, like, we have to draw a line parallel to the ground. Okay, so let me put it a dotted line. Something like this. Now the angle of depression, let's say that initially this vehicle is at point A, and the angle of depression for this is around 30 degrees. Right, so if you can clearly see that this line is parallel to the ground level, so of course this angle will also be equal to 30 degrees. Right, now in the same way, let's say after 12 minutes this angle changes to 45 degrees. It's like this, 45 degrees. Alright, now the angle becomes this way. Alright, it means the car is at point B, and from moving A to B it took around how much time? It took around 12 minutes. Right, so this is A, B and C. Over here this is D. Okay, now the question is, like, how much time will the car take to reach to the tower? Okay, so let's go ahead. Let's say height of the tower is this distance is A and this distance is B. Okay, now tan 45 degree equals to h upon a. Now you know very well that at tan 45 degree the value is 1, and so this h will be equal to a, right? Moving on to the next point, it's about tan 30 degree, right? This will be equal to h upon a plus b, right? Now tan 30 degrees 1 upon root 3 equals to h upon a plus b, or this one a plus b, this will be equal to under root 3 h, right? Now you know very well that this h is actually equal to a, right, as per the first equation. Fine. So we can say that this is h plus b equals to root 3 into h, right? Or you can put it like you can put the value of a as well, like a plus b, this is equal to root 3a, right? Now b equals to root 3a minus a, or b equals to root 3 minus 1 into a, right? Okay. Now let's say speed of car is v, and it is mentioned that this is moving at a uniform speed, right? So to travel a distance, it took around 12 minutes, right? Distance upon time. You can find it out like this, right? Now 1 minute, this is equals to 60 seconds. So 12 minutes, this will be equal to 720 seconds, right? Now V will be equal to B upon 720 seconds, right? Now if I divide get this equation both sides by 720 seconds, this will be equal to 1 to A upon 720. This is another point, right? Now this velocity to travel a distance A, this will remain same, right? So we can say that this B upon 720, this will be equal to root 3 minus 1 into A upon 720, right? Now consider this as first equation. Now to travel a distance of A from B to C, let's say again this velocity will be remain same. Why? Because this velocity is uniform, right? So let's say the time required to travel a distance is t. So this will be equal to a upon t, right? So this a upon t, that will be equal to speed, So that will be equal to root 3 minus 1 upon 720 into a. We can equalize both of them. And so this is equal to a upon t equals to root 3 minus 1 into a upon 720. This a can be cancelled out. And now what will happen? This will be equal to 720 upon root 3 minus 1. So this t will be equal to 720 upon 1.732 minus 1, that is 0.732, right? 0.732. Now what you can do is like you can just calculate this time in seconds. So this will be like you can say you can just go ahead and divide it 720 by 0.732. So that's come around 983 seconds. Fine. So this 983 seconds are required to travel the car from point B to C or to reach directly to the tower. Right? Now, the next point is move ahead to the next question, that is question number 7. The shadow of a flagstaff is 3 times as long as the shadow of a flagstaff when the sun rays meet the ground at an angle of 60 degrees. Find the angle between sun rays and the ground at the time of the longer shadow. Okay. Again, let's say this is the ground, okay, and this is a flagstaff, fine. And now let's say this angle is 60 degrees, fine. At this point of time, the length of the shadow is x. Alright. Now, at certain angle, what happens that this shadow becomes 3 times, right? I have no idea about what is this angle. Let's say this angle is theta, right? Now this time, so initially the length was x. Now this time the length is 3x. This is 3x. And at every time the height of the tower remains constant, that is h. Now if we try to solve this question, we can say that this tan 60 degrees, this is equal to h upon x. Now tan 60 degrees is root 3. This is equal to h upon x. And so this h will be equal to root 3 x, right? This is the first equation. Now, in next case, we have tan 30 degree, not tan 30, sorry, this is tan theta, it's not known to me. Tan theta, this is equal to h upon 3 times of x, right? Now, 3 times of x into tan theta, this will be equal to h, alright? So this is like this as our second equation. Now as you can see that in both cases, left hand and right hand side, these are the equal to h, so we can equalize them directly. We can have it like 3x into tan theta under root 3x. Now tan theta, this is equal to root 3x upon 3x, and so this will be equal to 1 upon root 3, and I'm sure now you got the answer for which value of theta, tan theta will be under root 3, that the required value is 30 degrees. Alright, this is the final answer for the question number 7. Now moving on to the next question. Question number 8. An aeroplane at an altitude of 200 meters observes the angles of depression of opposite points on the two banks of the river to be 45 degree and 60 degree. Find the width of the river. Okay. Now let's say this is the river, and here this is the plain area, and at certain point from here at an altitude of around 200 meters, there is a airplane. Okay. Now these are the angles of depression. So for, as you know that for angles of depression, what we have to do is for the first time is like we have to draw a line which is parallel to the ground level. That is like this. Fine. Now, yeah. So at some point, this angle is 60 degrees and this angle is 45 degrees. Fine. Now let's say in this case, this angle will be 60 degree and this angle will be 45 degree. This is x and this point is the distance between, let's say, this is A, this is B, this is C, this is D. The distance between CD is X, the distance between BC is Y. And so tan 60 degree, this is equal to 200 upon Y. Now tan 60 degree is under root 3. So this under root 3 will be equal to 200 upon Y, or this Y will be equal to 200 upon root 3. Fine. Now, next point, that tan 45 degree, this is equal to 200 upon x plus y. Okay. Now we know that the value of tan 45 degree, this is equal to 1. So this will be 200 upon x plus y. Now this x plus y, this will be equal to 200, right? And from this first equation, you have already proved that the value of y is 200 upon root 3. So this x will be equal to 200 minus 200 upon root 3. Fine. So I hope now you can do this. If we go ahead upon the setup, like we have 200 upon root 3, that is 200 upon 1.732. This will come around 115.5. So we can say that this is 200 minus 115.5. Alright, now you can simply go ahead and subtract this, and you will find out the actual width of the river is around 84.5 meter approximately. Now the question number 9 says that two pillars of equal height and on either side of the road, which is 100-meter wide, the angles of elevation of the top of the pillars are 60 degree and 30 degree at a point on the road between the pillars. Find the position of the point between the pillars and the height of each pillar. Now, let's start it. Let's say this is road. This is 100-meter wide. Okay. Now we have two pillars over here. Like this is first pillar and this one is second pillar, and it is already mentioned in the question that these two pillars are of same height. And so let's say this is the first angle, this is the second angle. Alright. Let's say this is a point A. From here we have point B, C, D and E. Alright. Here we have 60 degree and we have 30 degrees. Okay. Now let's say this AC equals to x and AB equals to 100 minus x. Alright. Now let's say height of each pillar is h. Now let's try to solve this question. First of all, tan 30 degree equals to h upon x. Alright. Now tan 30 degrees 1 upon root 3 and this is equal to h upon x. Right? Now this x upon root 3, this is equal to h. Now let's consider that this is the first equation. Now about next angle, that is tan 60 degree. This is equal to h upon 100 minus x. Now tan 60 degrees root 3. This is equal to h upon 100 minus x. And so this h equals to 100 minus x times of root 3. Alright, consider that this is a second equation. Fine. Now you can see that on the left hand side we have h, so we can equalize both of them. So here we have x upon root 3 and this will be equal to 100 minus x root 3. And so, like you can perform the cross multiplication and this will be equal to x times of 100 minus x into 3 and so on. This x will be equal to 300 minus 3x. Alright, now you can say that this 4x will be equal to 300 and so this x will be equal to 300 upon 4. Alright, now this will be and 4 5s are 20. So this x will be equal to 75 meter. So we can say that this, the point of observation is 75 meter away from EC and 25 meter, that is 100 minus 75 meter away from BT. Now the height of the post, as you have already seen, that x is equal to 300 upon 4, right? Now x, let's put it 300 upon 4 only, and as you have already seen that h from the first equation, this is equal to x upon root 3. So we can consider it as h equals to 300 upon 4 root 3. Here we have root 3 upon root 3. So this will be equal to 300 root 3 upon 4 into 3. right? Now this will be cancelled out as 100. So this will be equal to 100 root 3 upon 4. So this will be 1.732 into 100. That is 173.2 upon 4. And you can simply go ahead and calculate this value. This will be around 173.2 upon 4, that is around 43.3 meter. Now it is already mentioned in the question that the height of both the poles is same. So this is 43.3 meter in height like this. Fine. Now moving on to the last question. The last question says that the angle of elevation of a jet plane from a point A on the ground is 60 degrees. After a flight of 30 seconds, the angle of elevation changes to 30 degrees. If the jet plane is flying at a constant height of 3600 root 3 meter, find the speed of the jet plane. Now, this is question number 10. We have a point over here. Let's make it as a ground part. This is the ground part. Alright. And at some point, there is a jet plane over here. And now when someone observes this jet plane from here, it makes an angle of 60 degrees. Alright. Moving forward, after some time, the jet travels some distance, and now this angle of elevation changes to 30 degrees. Now, this is the height, and let's say the height is constant over here. So let's say label the diagram and name it accordingly. So this height is around 3600 into root 3 meter. Fine. And it took around 30 seconds to travel this distance. This is A, B, C, D, and E. Okay. Now let's check out the horizontal distance first. Okay. So this tan 60 degree, this is equals to perpendicular upon base, that is 3600 root 3 upon BC. Tan 60 degrees root 3, and this will be equal to 3600 root 3 upon BC. Now this root 3 can be cancelled out, and this BC will be equal to 3600. Alright, let me mark it like this. Okay, so BC we can say this is 3600 meter. Now take about tan 30 degree. Tan 30 degree is 3600 root 3 upon BD. Okay. Now tan 30 degrees is 1 upon root 3. This is equal to 3600 root 3 upon BD. Alright. And so this BD, this will be equal to 3600 root 3 multiplied by root 3, and this will be equal to 3600 into 3. Now the distance, that is CD, this will be equal to BD minus BC, and so this is 3600 into 3 minus 3600, and this will be equal to 3600 into 3 minus 1, that is 2, and this will be around how much? This is 3600 into 2, that is 7200 meters. Right? Now, in order to travel the CD, a plane took 30 seconds. That means in order to travel 7200 meters, the plane took 30 seconds. So the velocity, as you know very well, this is equal to distance upon time. So this is 7200 upon 30. 7200 upon 30 into 6 240 meter per second. This is 240 meter per second. So that's the required speed of the plane. So I hope the concept is clear to all of you. Have a nice time. Take care of yourself. Bye bye.